if you think about those basic graphs we did, what's the difference between what y equals x looks like, what y equals absolute value looks like, and what it looked like when you put it in a bracket? They're all linear. Any memories of? Straight vertical up and down? Okay, you all buying that? Y equals x is straight up and down, it's a vertical line. Think about if you did a t-table. If you put 1 in for x, what are you going to get for y? If you put 1 in for x, y is going to be 1. If you put 2 in for x, y is going to be 3, 3. That's not going to be a vertical line. It's a diagonal line. It's a perfect diagonal line. And then, of course, what if I wanted it to be steeper or flatter? Yeah, you change the slope. If I want it to come down diagonally in the opposite direction, how do I make it start at the top left and come down to the bottom right? You put a negative on it. Change the slope, make the slope negative. That's all it was. Since these were linear, we could talk about it in terms of slope. Okay, absolute value is a V. Yeah. Absolute value graphs are always V's. And I'm not sure I got that exactly equal there. No, that's crooked. But I still can't draw it. I give. One last try or I'm quitting. That's better. Okay, absolute values of V's. How do you know what slopes to put on them? The number in front is still the slope. So if it's a slope 2, you rise 2, run 1, rise 2, run 1. Same exact thing. It's just like a line. It's just that it has to go diagonally in both directions. Exact same thing. Okay, this is the one they were asking me about last block. What is the one in the bracket? It was the funkiest graph you'll ever saw. Oh, yeah. It's that one, yes. It's greatest integer. So if you recall, you started with a closed circle at 0. You went over 1 unit, and it was open. Then what happened? Yeah, you jumped up 1. You went over 1 unit, opened it, and it just keeps stair-stepping up and downward in both directions.
I'll be back tomorrow, and I'll just plan on doing those snowball. I'll just come so I can do those snowball balance and everything.
If you want me to send Emma or Janie to see about getting approval for crazy apparel today? Janie. Okay.
And I was thinking on that Tuesday, if you have a board meeting, we could do like board meeting first and do that.
Okay,
the date was already
well, that's a good choice. Okay, next time you're going to miss the K meeting, Miss Secretary. You need to have arrangements made for somebody to be the secretary.
I did.
Oh, who was?
Nicole.
Okay, so you would arrange it. I thought they just asked at the last moment. Okay. All right. See, you didn't have any leftovers. Okay. Oh, right. Shoot, that whole conversation just went on the video. Right. All right. Well, meanwhile, do you remember how to shift graphs? It's the exact same way as you just shifted your parabolas. If I said take any one of those graphs and make it go up 5, what would you do? You put plus 5 on the end of it. They would all go up 5. Doesn't matter what graph you're drawing. They all shift the same. If I took this absolute value and I put an x minus 4 and a plus 2 inside, where's it going to shift? Because it's exactly the same as the parabolas you just did and the conic sections you just did. Doesn't matter what function it is, it's going to go right 4, up 2 every single time. Doesn't matter. So it can be, the only thing that changes is the fact that one's an absolute value and you go, oh, I got to draw V. The other one's squared, so, oh, I got to draw a parabola. The type of function tells you what shape it should be, but otherwise the shapes are the same forever. Every graph we will draw second semester, every graph of a trig function logarithms, you name it. They all follow those rules, just without change. The best thing ever. I didn't learn that, and we didn't mathematically know that when I was in high school. Every graph I ever drew, I plotted in a t-table and subbed a number in for x and figured out y. Put another number in for x and figured out y. Until technology came along and we could do graphing calculators and see how the graph changed, we didn't graph this way, and it's so much better now. On. If I threw a 2 in front of a parabola, we know the graphs of parabolas are 1, 2, 3, 1, 4, 9. What did the 2 do to it? What did you do when you had a 2 in front? You doubled all your y's. You went 2, 8, 18. That's the same thing happening here. If I throw a 2 on that line, that's changing slope, but it's all it's doing is it's changing the rise. The y-coordinates are all going double. It works the same every time. You throw a number in front of any function, it changes the y-coordinates every single time. Once you learn the patterns, it makes, every time you're introduced to a new graph, you just have to learn a new shape. The rest of it, the shifting, the flipping, all of that is the same. It's amazing that this works. Okay, this came up last block. If you look at 15, B, and C, what extra step do you have to do on those two graphs? 15, B, and C. Shading and dotted because they have inequalities. They have less than and greater than, so don't forget about the shading and inequalities. Okay, remember that this is all going to be multiple choice. So how am I going to have you graph multiple choice? I'm either going to give you an equation and 4 graphs and say which one of these is the right graph, or I'm going to give you a graph and give you 4 equations and say which one of these equations would go with that graph. So if you know these rules about how it shifts and flips, you should know whether you're getting the right thing. Okay, now from there, you all have to tell me what we need to talk or not to, what I need to ring your bells about. 16 last block caused some concern. I'm pretty sure we just did elimination and substitution with conic sections, so I'm going to hope you can still eliminate and substitute. But do you remember they were worried about Cramer's rule? And notice the letter D is matrix equations by calculator only. I'm not having you do that by hand. Do I need to ring your bells on how to do either of those? Cramer's rule? Cramer's rule was the one and it was still a system of equations. But Cramer's rule was the one that had determinants in it. That ring a bell? Okay, the question was, which numbers did you put where? The bottom was always what? Yeah. Yeah. Your x and y coefficients always go in the bottom. That's always the same. So on top, you change one column. Well, you change what you're solving for. So if we're solving for x, you change the x column. What do you change the x column to? Yeah, the 8, negative 6, the numbers it's equal to. You don't change the y column at all. It just sits there happy as a clam the way it is. So down here, when I want to solve for y, I would put the 8 and the negative 6 in the y column, so what goes in the x column? The 2 and the 4. Okay, now other question? How did you work out what number? What do you do to work out that little 2 by 2 determinant? You cross multiplied, so you went 8 times negative 5, 3 times negative 6. So that would be negative 40 minus, and that's the key thing. Remember, you subtract, 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 subtract. So that number in the middle, add negative 40, add negative 18, but you subtract in the middle of it. That's key, key, key. That's the number one mistake I see. So what am I going to get then? It's really going to be a plus. Negative 40 plus 18, I believe, would be negative 22. So then cross the bottom. You're going to get negative 10 and 12. What goes in the middle? Minus. You're subtracting. And negative 10 minus 12 is going to make a negative 22. And so what's your answer for x? Positive 1 when you divide it. X is 1. Do you have to rework all of the bottom determinants? Yeah, we know the bottom is still going to be negative 22. So you don't ever have to rework it the second time. Just do the top, which would turn out to be negative 12 minus 32, which would be negative 44 over negative 22, which is a nice round 2, and you will get a coordinate of 1, 2 where they intersect. That rings a bell. That was one I was worried about. The other one I'm worried about, like I said, I'm only having you do matrix equations by calculator. By calculator was how you could solve the ones that had like 5 equations with 5 variables. Because the calculator can do that thing. But my question is, A, how do you set up the matrix equations? And B, what do you tell your calculator to do? So like if we were going to take this same problem we just did right here and I was going to turn it into a matrix equation. Okay, before that you got to set up what numbers go in which matrix. It was a matrix times a matrix equals a matrix. What went in the first matrix? Matrix is under menu matrix create. What's the next choice? I think it's menu matrix create. I'm not. Okay. So which numbers go in which matrix? So yeah, the first matrix is the x's and y's. The second matrix is the variables x, y. And then it equaled 8, negative 6. Did it live? Okay. So you have it set up. Then when you go to solve it, if you recall, we were trying to move this matrix over to the other side, and you can't divide a matrix. So what did you do to move it if you can't divide a matrix? You multiplied it by the, but it's kind of like that, but we can't do the reciprocal matrix. It's called the what matrix? Close? Inverse matrix. Yes, you multiply by the inverse matrix. Remember inverse first? So when you want to solve for x, y, you're going to have to tell your calculator to take the first matrix but put the inverse symbol on it, the little negative 1 power symbol. You just hit your caret key and put a little negative 1 power up there. And then you multiply it by the 8 and negative 6. And your calculator will produce the answer. If you were doing it by hand, you don't have to do it by hand, yeah. I just can't have you do every single thing we did and go back and do it again. There just isn't time. Sorry. You should feel happy. You saw pre-calc reviews? You guys have 6 pages and 2 problems. They have 10 pages. Learn a lot of different stuff over the course of the semester. Alright, from there, now we're up to October, November, what we've done in the last 2 months. Probably you were a refresher, and actually we've been using it more. You kept reusing it. So I need you guys to look from 17 on and tell me if you spot things going, oh, I don't think I remember how to do that.